So let's dive into AP Calculus BC 2025 FRQ, beginning with problem 1 in the calculator section. So we're told an invasive species of plant appears in a fruit grove at time t equals 0 and begins to spread. The function c, defined by c of t equals 7.6 arc10.2t, models the number of acres, so note that I'm noting down the unit there, in the fruit grove affected by the species t weeks after the species appears. It can be shown that c prime of t is equal to 38 over 25 plus t squared. Okay, so we've underlined the essential information. With that, let's jump to focusing on part A. So we want to find the average number of acres affected by the invasive species from time t equals 0 to time t equals 4 weeks. And we're asked to show the setup for our calculations. So again, I want to note keywords. We're being asked to find the average number of acres. And what we'll note if we look at the problem statement is that the number of acres is defined by C of t. In other words, we're looking for average value of C of t. And so with that, we can go back to the definition of the average value of a function. The average value of a function will be 1 over b minus a, integral from a to b of C of t, in this case, dt. And if we flesh out the details, in this case, that would be 1 over 4 minus 0, integral from 0 to 4, 7.6 arctan of 0.2t dt. And at this point, we go ahead and plug that right into a calculator. And plugging into Desmos, that gives me an answer which is 2.78. And of course, a unit which is acres, 2.78 acres. So let's move on to part B. Part B asks us to find the time t when the instantaneous rate of change of c. So instantaneous rate of change of c, I'm going to immediately write down, is c prime of t. We want to know when that equals the average rate of change of c over the time interval 0 to 4. Now, what is average rate of change of c over that time interval? Well, that would just be c of 4 minus c of 0 all over 4 minus 0. If this is reminding you of mean value theorem, you're reminded correctly. We're not being asked, though, to show that a solution exists, simply to find the solution. So there's no reason for us to state the mean value theorem for this problem. Instead, we simply have an equation that we need to solve. We know that c prime of t is equal to 38 over 25 plus t squared. So 38 over 25 plus t squared is equal to 7.6 arctan of 0.2 times 4 all over 4. And so now we'll go ahead and look at Desmos. Sorry, 3, 2, 1. So I've gone ahead and plotted 38 over 25 plus x squared. That representing our instantaneous rate of change, and then I've gone ahead and plugged in y equals to the average rate of change. And what we can quickly see, we only care about our positive solution, is that those intersect at t equals 2.15, where y is equal to 1.28. With that, we can state that our time at which the rates are equal would be at t equals 2.15 seconds, or sorry, in this case, the unit would not be seconds at all, 2.15 weeks. And if we were asked to find the rate, we would say 1.28 acres per week. But at this point, we're not being asked that. Moving on to part C, we're asked to assume that the invasive species continues to spread according to the given model for all time t greater than 0. Write a limit expression that describes the end behavior of the rate of change in the number of acres affected by the species. Evaluate this limit expression. So let's make sense of this. we're asked to find the end behavior of the rate of change. Namely, we're asked to find the lim as t goes to infinity of specifically c prime of t. And so remember that c prime of t, we've been told, is equal to 38 over 25 plus t squared. And so that is a fairly straightforward limit for us to evaluate. That limit is simply equal to 0. In other words, what this is telling us is that as t goes to 0, eventually we stop spreading, which potentially can be a consequence of having fully infected bee growth. This is also consistent with the actual function we're looking at, namely arctan, which we know asymptotes. So moving on to part D. At time t equals 4 weeks after the invasive species appears in the fruit grove, measures are taken to counter the spread of the species. Okay, that's fairly unimportant, except for the time at which this begins. The function a, defined by a of t equals c of t minus integral 4 to t 0.1 ln x dx, models the number of acres affected by the species over the time interval 4 to 36. So we can see that there's a mitigating effect. And we'd like to know at what time does A attain its maximum value. Now, this is a problem that often throws people off because they're trying to think too hard ahead. Let's just go and follow through with definitions. If we're looking at where a function attains its maximum value, our first step is to find critical points. And so that means we're going to go ahead and look at what A prime of t is. So A prime of t is equal to c prime of t minus d by dt, integral 4 to t 0.1 ln of x dx. Now we already know the value of c prime of t, that is 38 over 25 plus t squared. And using the fundamental theorem of calculus, we can easily compute d by dt of our integral. That will simply give us 0.1 ln of t. And so now we want to know when this is equal to 0, so let's go ahead and have a look at Desmos. So I've gone ahead and plotted in Desmos our two functions, namely 0.1 ln x, 38 over 25 plus x squared, and seen where they equal each other, at which point our derivative will be 0. And as we can see, our answer is 11.44. Another option, of course, is to directly plot the function. And that's also a good check of your work. We can see that indeed this achieves a maximum at t equals 11.44 seconds. And so let's jump right back. And it seems we're only asked to show the time at which it attains its maximum value and not the actual maximum value. And so we can say t is equal to 11.4 weeks. And with that, we finished problem 1.